Okay, last thing for this set of problems, what we call quadrantal angles. So this is a bit of a big deal. Quadrantal angles, the terminal side of the angle is on an axis, either the X or the Y axis. Key thing is, or one of the things about them is, quadrantal angles do not have reference angles. So if you think about it, got the initial side, like if I made a 90-degree angle right here. So I got a 90-degree angle. That's considered a quadrantal angle. The terminal side is on an axis. There's no way I can make an angle less than 90 degrees with this and this. And more specifically, between 90 and 0. So thus, quadrantal angles do not have reference angles. So if I had an angle like 180 degrees, so there's my angle right there. You say, okay, I'm on the y-axis, so there's no way I can draw an angle connecting this with itself, thus it has no reference angle. Kind of get the idea there. Going negative direction, like if this is my initial side, and I go over here. So there's my angle right there. So we can call it either negative 270 or negative 3 pi over 2. That's quadrantal because my terminal side is right there. Now, what's going to happen is when we start coming up with the values, for things like 270 or 180, you're going to say, well, I'm going to think about what's going on at that point. People are going to be tempted to say, well, the reference angle is 90 degrees, but that's technically not true. Technically, it's not true that you would call it a reference angle of 90 degrees. And the last possible thing would be like either positive or negative. Like if I did negative 360 or negative 2 pi, you're on an axis. So that's a reference angle. Similarly, if you went in the opposite direction, positive 360, positive 2 pi radians. Anyway, so quadrantal angles their terminal side is on an axis. They do not have reference angles.